Now let's take a look at decision testing and coverage. A decision is a program point at which the control flow has two or more alternative routes. A node with two or more links to separate branches. So basically, if you are a developer, a decision is where you have an if, where you have an expression, where you have a condition that needs to be addressed. And basically, independently of the size of the condition, because you can grow the condition with the logical operators, the output of the decision is always a true or a false. When considering decision coverage, the idea is to have a percentage, so it's another metric, that allows you to know exactly how many of the decision outcomes of an entire block of code are actually exercised by a test suite. So if we're trying to achieve 100% decision coverage, we are trying to achieve ultimately 100% branch coverage and 100% statement coverage also, okay? Because decision coverage, as we will see, is a very strong metric. These are also ISTQB definitions. The decision testing technique derives test cases to execute specific decision outcomes. So when considering a test case, we are trying to exercise all the outcomes possible from a specific decision or a specific branch. Branches form decision points in the code. Decision coverage is determined, so it equals the number of decision outcomes covered by the designed or executed test cases divided by the number of all possible decision outcomes in the code under test. Decision testing is a form of control flow testing as it generates a specific flow of control through the decision point. So it specifies a path, a flow that goes through the execution of your code. Decision coverage is stronger than statement coverage. 100% decision coverage for a component is achieved by exercising all decision outcomes in the component. When you have 100% decision coverage, you have guaranteed that you also have 100% statement coverage. But be aware, the opposite is not true. So you cannot say that if you have 100% statement coverage, that you have achieved 100% decision coverage. We will see that in a couple of seconds in our examples. And by speaking about examples, let's look at one of the examples that we have previously seen for the statement coverage. So in this example, a simple, very simple example, visually, we have this representation. So we can actually see that if we want to try to achieve 100% statement coverage, we only need one single test case designed. But if we are trying to achieve 100% decision coverage, we have to address all the possible outcomes that come from exercising this decision. I only have one decision in line 1. But there are two possible outcomes. The first one is true, yes, and the other one is no, false. So in order to exercise those two outcomes, I have to have at least two test cases to achieve this. And this implies that, for instance, for test case number 1, I can design the same test case that I had previously designed for the statement coverage. So I only have to ensure that age is lower than 17. And for test case number 2, I could put age, for instance, at 30, and I definitely will exercise this branch. So I will not be having an error message displayed. This earlier example that we have already addressed has this visual representation. So for achieving statement coverage, I had to define at least two test cases because I had two statements that were on opposite branches of the decision, and I had to execute one test case to ensure that line number 2 executed, and another test case designed for ensuring that line number 4 is executed. So, to address the 100% decision coverage, these two test cases that were previously defined are the ones that are needed to achieve the same amount of percentage for decision coverage. This one is a new example. So I have an A, I have a B, I have a C, and I have an X. So considering all of these codes and lines of code, I have one single statement. The statement is present at line number 3. I have two decisions. The first one is present in line 1 and the other is present in line 2. If I represent the lines of code visually, I get a diagram that is similar to this one. If I'm trying to achieve 100% statement coverage, I only need one test case because line number 3 is achieved if I exercise test case number 1, and I'm addressing 100% statement coverage. But on the other hand, if I want to address the 100% decision coverage, I have to make sure that the outcome from decision number 2 that assesses as false or no is also tested, and the outcome of the first decision is also assessed as a no or false. So this implies that to achieve the 100% decision coverage, I have to have at least 3 test cases. Let's take a look at the design or the test conditions for each of these test cases. So a good example for test case number 1, the one on the left, would be to address a value for A that should be greater than B. So A could equal 10 and B could equal 2. Then I would have to make a decision in order to allow that C would also be lower than A. So if A is 10, B is 2, C could be 3. Okay, so if A equals 10, B equals 2, C equals 3, and X has any value that you want because X is quite irrelevant, A gets a new value. A gets to be A plus X. Okay, and this is the way to design a test case that could be one of the possible values defined for the test case number 1. If I want to address test case number 2, A should be greater than B, so we can stick with A equals 10 and B equals 2. But then I have to exercise the second branch of decision number 2. So I don't want to have this A bigger than C or A greater than C being assessed as true. So I have to establish that the value for C must be greater than 10. So C could be 20. So test case number 2, A equals 10, B equals 2, C equals 10, 20. So A is not bigger, greater than C, and then I will end my code. To define test case number 3, I only have to ensure that the first condition is assessed as false. So A should be lower than B. A could be equal to 2 and B could be equal to